Hey there, and welcome back to How'd You Get That? Today we are looking at this logarithmic problem. Find the intersection point or points of these two logarithmic functions. F of x is equal to log base 2 of x minus 1, and g of x is equal to log base 4 of x plus 11. So in order to find the intersection points, all I need to do is set these two functions equal to each other. So log base 2 of x minus 1 is equal to log base 4 of x plus 11. Now the first thing I want to do here is get both of these logarithms into the same base. So let's try to get them into base 2, since that's a simpler base than base 4. There are a couple of ways to do this, but the one way we can figure this out is by using the change of base formula, and that is this. The log base b of a is equal to the log base c of a over the log base c of b, where c can be any base that we choose. So it could be log base 10, it could be log base e, it could be log base 2. So let's try to make this log base 2. So the log base 4 of x plus 11 is equal to the log base 2 of x plus 11 over the log base 2 of 4. Fortunately, the log base 2 of 4 is pretty easy because remember, that's asking the question, what is the exponent such that 2 to that exponent is equal to 4? Well, that exponent is just 2, so log base 2 of 4 is just 2. So now I have this equation. Log base 2 of x minus 1 is equal to log base 2 of x plus 11 over 2. Here's an important property of logarithms to consider when solving this problem. If I have a number that's being multiplied outside of the logarithm, for instance, on the right-hand side here, we have a factor of 1/2. When I divide it by 2, that's the same thing as multiplying by 1/2. That multiplicative factor outside the logarithm can jump inside the logarithm as an exponent on the argument of the logarithm. So instead of 1/2 times log base 2 of x plus 11, I now have log base 2 of the square root of x plus 11, remembering that the square root is the same thing as the 1/2 power. So now I have this equation. Log base 2 of x minus 1 is equal to log base 2 of the square root of x plus 11. Now it stands to reason, because the logarithms have the same base, that their arguments must be equal to each other. So now I can say x minus 1 is equal to the square root of x plus 11. Now the next thing I want to do is square both sides, but we have to be careful here, because sometimes when I square a function like this, I can get erroneous solutions. So we're gonna just need to check all of our solutions at the end to make sure they're both valid. Okay, so when I square both sides, I get x minus 1 squared is equal to x plus 11. Doing some FOIL on the left-hand side there, we get x squared minus 2x plus 1 is equal to x plus 11. I'm now going to combine like terms, set everything equal to 0, and I get this formula. X squared minus 3x minus 10 is equal to 0. Now this is just a quadratic, which is nice and simple to solve. We can use either the quadratic formula or factoring to figure out what the solutions to this must be. Fortunately, this is factorable. What two numbers multiply to -10 and add to -3? Well, those numbers could be, for instance, -5 and +2. And in fact, that works. So the factorization of this quadratic function is x plus 2 times x minus 5. All that is equal to 0. So the solutions for x must be -2 and +5. But remember that one of these solutions might be erroneous. So let's plug each of them into the functions f and g just to make sure that they get valid solutions. So f of -2, for instance, is log base 2 of -2 minus 1, which is equivalent to log base 2 of -3. But remember that the argument of a log can't be negative, so -2 is actually an invalid solution to this problem. So we're left with a solution of +5. Let's make sure that works. So f of 5 is equal to log base 2 of 5 minus 1, which is equivalent to the log base 2 of 4, which is equivalent to 2. And g of 5 is equal to the log base 4 of 5 plus 11, which is equivalent to the log base 4 of 16, which is equal to 2. So g of 5 is equal to 2, which is equal to f of 5. So these functions intersect at the point 5, 2. If you have any questions, leave them in the comments below, along with any suggestions you might have for future episodes of How'd You Get That? Hit that like button, subscribe, and hit that notification bell so you never miss another math, physics, or problem-solving tutorial. Thanks so much for watching, and I'll see ya in the next problem.